Good morning students. Bond enthalpy or bond energy. Energy is required to break a bond. Similarly, energy is released when a bond is formed. Accordingly, there are two types of bond enthalpy or bond energy. First one is bond dissociation energy or bond dissociation enthalpy. Bond dissociation enthalpy. This is in the case of diatomic molecules. So, what is bond dissociation enthalpy? It is the amount of energy required to break a particular type of bond in 1 mole of diatomic molecules in the gaseous state. So, what is bond dissociation energy? It is the amount of energy required to break a particular type of bond. To break a particular type of bond in 1 mole of diatomic molecules. Okay? 1 mole of diatomic molecules. One mole of diatomic molecules in the gaseous state. That is important. In the gaseous state. Okay. So this is associated with diatic molecules. Example, H2, Cl2, etc. Okay. That is H2 in the gaseous state. H2 molecule dissociated to H atoms. And its delta H. Bond dissociation enthalpy is found to be 435 kilojoule molemole. Another example, Cl2 gas dissociates to 2Cl atom. Okay, here the delta H is found to be 242 kilojoule molemole. Okay, this is the first type of bond enthalpy. Okay, second one is mean bond enthalpy. This is associated with polyatomic molecules. Second one, mean bond enthalpy. Mean bond enthalpy is the average amount of energy required to break a particular bond in 1 mole of polyatomic molecules in the gaseous state. Okay, so it is the average amount of energy required to break a particular type of bond in 1 mole of polyatomic molecule. In gaseous state. Okay. So, in polyatomic molecules, it is associated with polyatomic molecules. Example, H2O, then CH4, etc. CH4, etc. Okay. Now, let us take an example, H2O. Here, bond enthalpy is not same for two successive bonds. So, in the case of H2O, there are two successive bonds. Two OH bonds are present. Two OH bonds are present. Okay, there are two successive bonds are there. In both these cases, the bond dissociation energies are different. That is, first case, HOH, H plus OH. Okay, Here delta H is found to be 498 kilojoule. Okay. Now the environment changes. Only OH bond is there. This H breaks. Okay. So next OH breakage. Here delta H is found to be 430 kilojoule. Okay. So both are different. Now we have to find mean bond enthalpy. Okay. The average of these two. That is 498 plus 430 by 2. Like this we can find the bond enthalpy 464 kilojoule mole inverse. Okay. So this is an example. Now using Hess's law, bond energy can be calculated from enthalpies of reaction. Okay. Hess's law, using Hess's law, bond energies can be calculated from enthalpies of reaction. Now let us do one problem based on this. Calculate the bond energy of HCl. Given enthalpy of formation of HCl is minus 91 kilojoule mole inverse and bond dissociation energies of H2 and Cl2 are 430 kilojoule mole inverse and 242 kilojoule mole inverse. So using the enthalpies of reaction, we can find the bond energy of HCl. Okay, so bond energy of HCl we have to find for the breakage of HCl. Okay, that we have to find. It is given, the bond formation is given, that is half H2 plus half Cl2 gives HCl. Okay, delta H equal minus 91 kilojoule mole inverse. This much energy is released. Okay, next second equation, bond dissociation energies of H2 and Cl2 are given. That is H2 dissociates to 2H. That is given delta H. It's given 430 kilojoule mole inverse. This is second equation. Similarly, Cl2 gives 2Cl, delta H equal 242 kilojoule mole inverse. All these are given. Now, next what we have to do? We have to divide these 2 and 3 by 2. So what happens? H2, half H2 gives H. Okay, dividing by 2. And this delta H gets converted into 430 by 2. So 215. Similarly, chlorine also, half Cl2 gives Cl. Delta H will be 121. Okay, first we have to divide these two equations by 2. Then next we have to add 4 and 5. So we are adding those equations. So H2, half H2 gives, dividing by 2, delta H equal 215 kilojoule mole inverse. Equation 4. Okay. Next, half Cl2 gives Cl gas, chlorine atom. Delta H will be equal to 121 kilojoule mole inverse. Okay. Fifth equation. Next, we have to add these two equations, 4 and 5. Then what happens? Half H2 plus half Cl2 gives H plus Cl. Okay. So, adding these two, 215 plus 121. Delta H will be equal to 336. Okay. 336 kilojoule mole inverse. This is equation 6. Next, what we have to do? We have to reverse this equation and add with this equation. What happens? Reverse. If we reverse this equation, this RHS gets converted into LHS. So HCl plus this equation, half H2 plus half Cl2 gives this half H2 plus half Cl2 plus this H plus Cl. Okay, question 7. Now dividing, cancelling these two, what happens? HCl gives H plus Cl. What happens to delta H? We are reversing this equation. So this sign changes. So this will be equal to 91 plus, add with this 336. Okay. So what will be the answer? Answer will be 427 kilojoule mole inverse. So this will be the bond energy of HCl. Like this we can find the bond energy of certain compounds. Okay. Next, use of bond energies to calculate the enthalpy change of reaction. Use of bond energies. So bond energies are given. We have to calculate the enthalpy change of reaction. So delta H of R is given. This is in gaseous state. Okay. So delta H will be equal to sum of the bond energies of reactants, sum of the bond energies of reactants minus sum of the bond energies of products. Okay. So this will be the equation. So using this we can calculate, we can do one problem. So calculate, example, calculate delta H is given H2 plus Br2 gives 2HBr. Bond energy, this is the equation. Okay, so delta H of R is R we have to find. Okay, so bond energies are given, bond energies HH, then Br bond will be there, then HBr bond will be there. So their dissociation energies are 435, then 192 and 364 kilojoule mole inverse. Now we can find delta H of R will be equal to sum of the bond energies of reactants. Here the reactants is H2 and Br2. Their dissociation energies are 435 plus 192 minus 2 into, this is the product, 2 into HBr is 364. Okay. Answer will be minus 101 kilojoule mole. Okay. So this will be the answer. So this much energy is released during this process, during this reaction. Okay.